Now, in this video, we're going to tackle about the fourth and fifth example for continuous variable probability. Now, let's proceed for the fourth example. Let x be a random variable with PDF or probability density function given by f of x is equal to cx squared, such that the absolute value of x is greater than equal to 1. Otherwise, find the constant c, find e of x and variance of x, and find the probability of x, which is greater than equal to 1/2. Now let's proceed with letter A. To find c, we can use this formula from our previous video as f of x of u du or f of x dx with lower and upper limits as negative infinity and infinity, and then equate it to 1. This is to solve for c. Now, for you to understand it, let's proceed with our solution. Now, 1 is equal to the following. F of x u du with limits of negative infinity to positive infinity. The next one is 1 now is equal to our f of x, okay, as cx squared. But since we're going to use u here with limits of -1 to +1. So this becomes 2/3 of c equal to 1. To solve now for c, okay, cross multiply 3 to 1. So this becomes 3 is equal to 2c, and then divide both sides of equation with 2. So c now is equal to 3 all over 2 or 3/2. Now let's proceed with letter B. To find now for the expected value, ex, we can write this in this way. E of x is equal to the integral of u of f of x multiplied with u du. Okay? So if we're going to factor out the constant 3/2 outside of the integral sign, this becomes 3/2 the integral of u cubed du with lower limits of -1 and upper limit of 1. Substituting the values or further simplifying this with power formula in calculus and substituting the upper and lower limits, since our upper limits and lower limits is 1 and -1 respectively, this is 0. Now to solve for the variance of x, we're going to use this formula from the other videos or previous discussions. This is variance of x is equal to ex squared minus the expected value ex quantity squared. Since we got ex, okay, at 0, so this cancels out. So we are left with variance of x, which is equal to ex squared. Now, substituting the following values, this gives us the integral of u squared f of x multiplied with u du with lower limit at -1 to our upper limit, which is 1. Okay. Now, if we're going to further simplify this, okay, this becomes 3/2 of the integral of u raised to 4 with limits of -1 and 1. Okay. And then further simplifying the integral, this is u raised to 5 all over 5 times 3/2. Further simplifying these calculus terms, this gives us 3 all over 5. Now, to find for the probability of x, which is greater than equal to half, we can write it in this way. The p of x greater than equal to half is equal to 3 all over 2, or 3 halves, with the integral of x squared dx with lower limit of half and upper limit of 1. Further simplifying the values, this gives us 7 all over 16. Now, let's proceed with the fourth example. Let x be a continuous random variable with probability density function PDF of f of x is equal to 4x cubed and 0, such that your x lies between the value of 0 and 1, or x is greater than 0 but lesser than equal to 1. Now we're going to find this relationship as the p of x, whereas it is lesser than equal to 2/3, and the other one, the inequality at x, which is greater than 1/3. So how are we going to do it? If we're going to represent this in mathematical terms, this is actually p of x, which is lesser than equal to 2/3 all over x, which is greater than 1/3. Now, I'm going to show you how we get these values. Now, for this solution, okay, for p of x, which lies, okay, lesser than equal to 2/3 all over x, which is greater than 1/3. In mathematical terms, this is p of 1/3, okay, whereas your x is greater than 1/3, but lesser than equal to 2/3 all over the probability of x, which is greater than 1/3. Okay. Now, solving for the values, this gives us the integral of our given equation of PDF at 4x cubed dx with lower limit at 1/3 and upper limit of 2/3. This is for the numerator only. For the denominator, all over the integral of 4x cubed with limits of 1 and 1/3. We're going to further simplify the following formulas for the numerator and denominator. We're going to use power formula. Now, after simplifying the whole equation, this gives us 3 all over 16. Okay, now that ends my presentation for continuous variable probability. For further questions, you may message me through my messenger account or our LMS inbox.